Welcome back, everybody, to this Tableau for FIRST Robotics video course presented by FRC Team 2834. This is Video 5, Advanced Charts Part 2, and we're going to be looking at using multiple dimensions in one chart. Let's get started. So here we are in Tableau. Let's think about the data you collect. All of the data that you collect is going to be on different robots, but it's also going to be across different match numbers. Thus far in Tableau, we've been making graphs of cumulative data across all those matches for a robot's performance. So for instance, we've taken a look at the sum of the auto low port scoring across all of a robot's matches, and we know that by right-clicking on that and measure, we can take a look at the average across all the matches, the median, minimum, maximum, all the different types of measures that we can look at. But what if I want to take a look at a robot's performance in a specific match, or better yet, how that performance in that match ranks against their performance in other matches? And this is where using multiple dimensions comes in. So I'm going to add a new sheet, and I'm going to call it multiple dimensions. Okay. So let's start with team number, and today we're going to go with teleop outer port. So we've got our bar chart, we know how to do that, great. So let's say I want to see this cumulative data, but I also want to see it by match. I can take my match number pill and I can drag it into detail. Let's take a look at what that does. Ooh, so now I can see that there's a divide, a very thin divide, but still a divide in these bars between a team's matches. So for instance, team 9991 scored 8 in match number 2, and they scored 5 in match number 1. They're divided bars right here. And cumulatively, I know that they scored 13 based on this axis. Great. Now, I can also drag this into color, and I can see a stacked bar chart like we made before, but instead of sorting by different measures, these are all the same measure, teleop outer port scoring, but the different colors are sorting the match numbers. So this might make it a little easier to look at, and we know from here we can edit the colors, and we know how to do that. We could also do size, and this is a little more of an interesting method. You get your bars, and a thin bar is match number 1, a thicker bar is match number 2, and it'll keep getting wider and wider as you increase your match numbers. But generally, I would use color. It looks a lot prettier, and it's just easier to interpret. So this brings us into our next major chart, and that is the box and whisker plot. So first, let's take a look at what a box and whisker plot is. Excuse me, my drawing skills are subpar, but this will give you a general sense of what a box and whisker plot is. A box and whisker plot looks like this. It's also called a box plot sometimes. And it is a way to display where all of your data points are in a distribution. So this is what's called a normal distribution, because all of the quartiles, they're called quartiles because it's divided into 4 sections. You have this 25%, this 25%, this 25%, and this 25%. And if all my quartiles are even, that's called a normal distribution. And if you think back to your high school statistics class, that's your bell curve and things like that. But what this box plot is showing me is if I have all these different data points across my chart, say like that, and say like this is an axis that's telling me my score, and then maybe here this is team number. But this is just for a specific team, say team 2834. So what this box plot is telling me is that 25% of my data is in each of these quartiles. And this combined 50% in the middle is a special rectangle called the interquartile range, and that is where 50% of all your data points are. Now, realistically, the distribution is not going to be normal, meaning it's not going to have a have quarters that are the exact same size. Each quarter will still hold 25% of the data points, but they won't be the same size. What's a little more realistic is a box plot that looks like this. And what this box plot is still telling us is 25% of our data is over here, 25% in there, 25% in this little section, and 25% in that section. So since 50% of our data is in this box, what we can really say from this is a majority of the robot's score is in this box. These are not outliers, but they're more maximums and minimums. And the robot is mainly scoring in this box. This is mostly what we can expect out of that robot. The thinner the box is, the more accurate their scoring has been across matches. The wider the box is, the wider their score distribution has been. So that's a basic gist of box and whisker plots. Oh, and this line in the middle is the median, and that's how you can easily sort box and whisker plots in Tableau. So you can do a little more research on those. That was a very basic and probably blurry explanation, but you can do a little more independent research on those if you don't know what box plots are. So we're going to make a box plot. I'm just going to take these away. So our box plot is going to be team number and teleop outer port. We get our bar chart. But now I want a box plot that has data points that instead of score, like I had on that drawing, the data points are going to be teleop outer port. And I want to see where the distributions are for everyone's matches. So I'm going to take match number and I'm going to drag it into detail. And here's where that show me button comes in. I'm going to hit show me and I'm going to go down to box and whisker plot. Now, you're also going to have to drag team number back up to here and match number back down to detail. Tableau flips them, your dimensions. Don't worry about it too much. It's just a little annoying thing that Tableau does. So here we are, our box and whisker plots. There were only 2 matches in our data, so we don't really have any whiskers, but we have boxes. And we can see this is called our upper quartile, this is our lower quartile, and this huge box is our inner quartile range. Let's try and interpret these a bit. This box is much smaller than the others. What that tells us is that this team's data is more concentrated into this area, and this team has been scoring not the most, but more accurately than these teams, because this team has been scoring up here and down here. This team has been scoring probably the most accurately because they've had 2 matches and they've scored the exact same thing. If we go to sort this from descending or ascending, it will sort by the median, which is where the different gray parts of the box meet. And these are really useful if you're looking at data points across several matches and you want to see how a robot has generally performed. Did they have outliers anywhere? And really it's to see what you can expect a majority of the time out of that robot. A majority of the time out of Team 9991, we're going to see between 5 and 8. But from 9988, they have a very wide gap in their scoring, and we're not really sure what we can expect from them because their box isn't as concentrated. All right, next time we're going to look at my favorite, calculated fields.